In magnetism, we have already discussed, we know about, here we basically will be learning about bar magnet, the magnetic field lines produced around it. Also, we'll be learning about the solenoid, the magnetic field lines, and we'll be discussing also about Earth as a giant bar magnet, and around it will be the magnetic field lines. See, an equally important another topic in this chapter is the last one, matter. So where's the matter found? In the core, right, in the core of the Earth here. Now, let's recall, while we were in childhood, even we used to take a bar magnet and go around and find things and see whether it's been attracting or repelling in nature. But what we usually found was attractive in nature. So what stayed in the back of our head was a magnet will be attracting the materials, but will it be always attractive in nature? The answer is no. Some of the matter, the materials, the substances which will be found in the earth will be actually repelling in nature as well. Yes, some may be attracting, no doubt, but few are there which will be repelling in nature. So now what makes them repel by nature? It's what we are going to discuss on today's topic. Diamagnetism. Okay, before I get into in detail about diamagnetism, what I want you to know is this chi factor. It's a Greek alphabet, and what it is actually a constant. Name is magnetic, say, susceptibility. Now actually this chi factor will be determining whether your materials found in the earth is diamagnetic in nature or paramagnetic in nature or ferromagnetic in nature. So how do we know that? If chi value is your negative, it is your diamagnetic substances. If it is positive in nature, we called it as paramagnetic, and if it is positive and even greater values, maybe like 10 to the power 3, so this will give you ferromagnetic substances. Alright, so we'll discuss about para and ferro in details in our next videos. These are also equally in-depth conceptual questions comes from these two topics as well. Let us more focus on diamagnetism in this case. So we'll be focusing more on para and ferro in later classes. This lesson is all about diamagnetism. Let's see how it is repelling to the external magnetic field applied to it. See friends, diamagnetism is all about your subatomic subatomic level. Now, to understand this material, we have to actually look the elements inside the atom, how it is reacting to the external field when it is applied. So in subatomic level, as we know that you have a proton and a nucleus, let's say a nucleus directly, then you have electron revolving around in this circular orbit. So this is your electron. Okay, now what happened over here is, see, what's the concept about magnetism is a charge moving will produce current, and in return will produce magnetic field lines around it. Now this electron charge, when it is moving in a circular orbit, doesn't it looks equivalent to your a current carrying circular wire, a loop, current carrying loop. So what we have found over there, in a current carrying loop, you will see magnetic dipole will be developed. We have seen the concept of magnetic field also over there. So we have this magnetic moment here. So that's why this electron, which has your angular orbital motion, as it has been equivalent to your current carrying loop, also equivalent to your current carrying loop. That's why we can say this electron will have your orbital magnetic moment. So students, you must also know that this orbital magnetic moments, maybe they all are in the same direction or maybe in the different directions. We don't know, because as we know, the electrons, when it has been placed inside the atom, are placed in different atomic levels. I'm giving you the extra deep core information, okay? As you know, SPDF is the shell in which the electrons are put. So there, the electrons, depending upon the energies, have the spin orbital moment different according to the energy levels. That is the reason why these electrons, different electrons in an atom, will have maybe same orbital magnetic moment or different orbital magnetic moment. Okay, now interesting thing comes over here. When the external magnetic fields are applied to, say, your diamagnetic substance, I have taken a bar of diamagnetic substance. Here, the electrons, okay, if I zoom in to this point, here, some orbital moments are like this, some are different like this, some are different like this, okay? Now the moment magnetic field lines are applied to this substance, what happens is the electrons having orbital magnetic moment in the, okay, let me change color and show you, same direction orbital magnetic moment. These are also same, no? They are going to slow down. But those in the opposite direction this one and this one are going to speed up. Say in this one and this one are going to speed up. You'll be up. Okay, in this process what happens will be a net magnetic moment will be developed. Now this net magnetic moment will be in opposite direction to the applied magnetic field. This is interesting, see, because some of them are slowed down and some of them are speed upped. So that will be creating a net. So this is your overall net magnetic moment, and that will be in the opposite direction to the applied magnetic field. So this is the reason why the diamagnetic substance repel to the magnetic field. So when magnetic field is applied to your bar substance, what happens is this bar is going to move away, repel, as if like a very strong field lines. It's going to repel from strong field lines towards the weaker field lines. It's going to repel like this. Okay, student, let me share an extra information with you. This is magnetic moment and this is your magnetic field. If they are perpendicular to each other, then this is your torque, which is your M cross B. So here if you take a magnetic needle and place it in your uniform magnetic field, then it's going to rotate. It's going to rotate, have a torque, rotational force. So another concept I would like to share with you, just now we have seen if this is your magnetic field line, then if magnetic moment is in opposite direction, it is your always repulsive in nature. Okay, you should know this, that all, even your para and your ferro, will be diamagnetic in nature. All the substances found is diamagnetic in nature, but a certain shift in para and ferro will what makes them different from diamagnetic, so which we'll be discussing in the later of our videos. The third one is if I have magnetic moment and magnetic field in the same direction, this is your para or ferro magnetic substance. Okay, so this was the extra information. Now some examples of diamagnetic substances found around you only, that is your water, H2O, then common salt, and copper, lead, bismuth, nitrogen. But at STP. Student, do you know what is STP? This is your standard temperature and pressure. Okay, standard temperature and pressure. Now, let's imagine that I have a bucket of water and a cup, a plastic cup, transparent plastic cup, and water is filled. Now this diamagnetic substance effect is very, very weak. This phenomena of diamagnetic, the self-repelling property to magnetic field, is very weak. For this to be visualized, you need a very strong magnet. For example, neodymium. So neodymium magnets are very strong magnet which will help us to see this diamagnetic effect in reality. Now, if I take the neodymium magnet, a strong magnet, and the water is like free to move in a situation is made. Okay, let me. So, for example, if I take the neodymium magnet and I have a setup like this, I have a bucket of water and I have a glass of water here. This glass of water is allowed to move freely. Now this magnet or say this ferromagnet water, this diamagnet water will be repelled. It will be moving in this direction. Again, if I take the strong magnet in this side, the water will be traveling to the other side. So this is the visible effect when we take the very strong magnet, because as I said that diamagnetism effect is very weak. Likewise, let's think of the copper example. If I want to break the glass over here, nothing in between, I have a strong magnet hanging here, then I make it swing in this direction. So what happens is this is going to break the glass first. But if I now insert or bring in front the copper diamagnetic substance here, this is not going to hit the glass, but instead this magnet is going to repel to the other direction. So this is the visual effect when we take the strong magnet of diamagnetic substance. So I hope you have understood today's lesson. In coming videos, I'm going to deeply discuss on the other two bound materials, paramagnetic and ferromagnetic. So with this, I'll end today's video lectures. Before I go, I would like you to write in the comment below, or do as an exercise and homework for me to know that you have truly understood the concept. So can you tell me, if I take the diamagnetic substance or bar, why the magnetic field lines is like this? I'm sure you will be seeing the same diagram in your book as well, why the magnetic field lines will be going on top of them and only few lines enters from inside. Thank you, class. This was me, Martha, your physics mentor. Bye bye.